So for question B, we're going to be seeing if the given units is either a power rating or an energy rating or neither of the two. So let's start with A. So the unit that we're looking at for part A is kilograms meters squared per second squared. So just a little side note, before we actually get into any of this, let's actually figure out what an energy rating is and what a power rating is. So we know power is equal to energy per time. And we know that energy is typically in joules, okay? So we can use that to determine if this is going to be a power rating. The next thing we're going to look at is the energy rating itself. So two common equations that we use for energy is kinetic energy and potential energy. Both those will give you the final energy units that you would use for joules. So let's look at kinetic energy first. So kinetic energy, as we know, is equal to half mv squared. We know mass is in kilograms. We know velocity is in meters per second, and we're going to square it so we can distribute it. So we can say meters squared per second squared. So we can see, and we know that kinetic energy is always in joules. So we can say that joules is equivalent to kilograms meters squared per second squared. Now, if you guys don't remember this equation, you also can remember the other, which is potential energy. And we also know that's measured in joules. And we see that potential energy is equal to mgh. And we know mass, again, kilograms. G is our gravitational acceleration constant, so that's 9.81 meters per second squared. And we know height is a meters value. So as we look through and see the interaction between all these individual units, we see that joules is equivalent to kilograms meters squared per second squared, which is the same thing that we got up here. So we see that joules is equal to joules, and if we need to, we can sub that into the top or the numerator of the power term. So getting back to question A, we see that kilogram times meter squared per second. We look at all this, we see joules is equal to kilogram meter squared per second squared. And we see that that doesn't match up. We're going to look at our power term. So if we put this over seconds again, because time is in seconds, we see that's going to give us a seconds cubed value, which again doesn't line up. So we can safely say that kilograms times meter squared per second is not equivalent to either energy or power. Part B of this question is looking at the units of kilogram meter squared per second squared. So now we're going to look at these not the unit conversions, but the unit analysis that we did before, and we see that joules is equal to kilogram meter squared per second squared. So we can safely say that this is equal to an energy rating. So that's a pretty straightforward one. This next one, part C, is where it's going to be a bit more tricky. So we're looking at quads per year. So the main way we're going to actually look at this is that we have to use our unit conversion sheet. So we know that one quad, is equivalent to 10 to the 15 BTU. Now this might not seem too helpful at first, but as we look even further, we see that 1 BTU is equivalent to 1,055 joules. So we see indirectly that quad, which is equivalent to BTU, is equivalent to joules in the end. So we can say that quad is an energy term, and then we also have a time value on the bottom, okay? And energy, I'm just gonna write that one more time. So as we saw before with all this unit analysis, we can see that power is an energy per unit time. So we can say that quads per year is a power term. So for question 2, part D, we're going to continue on by looking at the units and determining whether or not they're either power or energy. So the first one we're going to be looking at in part D is terawatts. This one's going to be pretty straightforward. As many of you know, TW stands for terawatts. Watts is a power term. What might confuse some of you guys though is the T in front of it, which stands for tera, as I've already said. And we know that tera is equivalent, so all it is a prefix, and that's equivalent to 1 times 10 to the 12. So all this is saying is that there are 1 times 10 to the 12 watts. And as all of us know, watts is a power rating, so we can safely say that D, terawatts, is power. So for part E of question 2, the unit we're going to be looking at is power servants. So power servant is a unit which is equivalent to 100 watts of energy input. So as we bring that down, we say power servant. We have power servant on top. We can put 1 power servant on the bottom. And we put 100 watts on the top. And as you guys know, watts is a power term, so we can safely say that power servant is equivalent to power, as the name might suggest with power right in it. The next one, part F. The unit that we're going to be looking at is power servants per day. So this one has a power term on the top, as we talked about in part E, and that's per unit time. So let's break this down a bit more to actually see what it turns out to be. So if we have a power servant as we've seen over here, I'm just going to rewrite this. So once again, I've just done the same thing. I've said that 1 power servant is equivalent to 100 watts. And we know that a watt is equivalent to 1 joule per second. Okay, so as we go through and do our unit analysis, we can cancel that out, we can cancel these out. And we see that we're left with joules per second. So power servant is equivalent to a unit of joules per second, which actually turns out to be 100 joules per second. But we don't need to worry about the quantity so much as we do the units. So we can say that this is equivalent to joules per second per day. Now with our definition of power, we know that power is equivalent to energy per time. Energy, which is commonly noted in joules, and time, which is commonly put in seconds. Now we see that we have joules per second per day, so we have 2 units of time in there, which doesn't work out. So we can safely say that this is not a power term, and it's not an energy term, so the answer is neither. So continuing on with question 2, we're going to be looking at part G. And the unit that we're looking at in this is kilowatt hours, so I'm just going to write it short in term, which is kWh. Now this is another one that a lot of people find tricky, so we're going to break this one down a bit more and to go in depth to see whether it's a power, an energy term, or neither. So I'm going to bring this down. So we know from many calculations that kilo means 1,000, and that's just a prefix as we saw with tera. So when kilo is equal to 1 times 10 to the 3 of whatever we're doing. So we can safely say that 1 kilowatt hour is 1,000 watt hours. Okay? Breaking it down even further, we know that 1 watt is equal to joules per second. Watt is a power rating, and that's just a rate. So we can say that 1,000 joules per second times hour. Okay? Now, as you can see here, we have time on top and time on the bottom. To analyze this a bit further, we're going to write this down. And we're going to see what we can do to cancel these out. So let's write hours on the bottom. And we're going to go with a unit that we know that is equivalent to 1 hour. So we can go to 60 minutes first. And we can multiply 60 minutes. We can say 1 minute is equal to 60 seconds. So we can see, if we look at our units, we can see that we have 1 hour and 1 hour canceling. We have minute and minute, and we have seconds and seconds. All that leaves us with is joules on the top. So we know our final answer is going to be some quantity. We're just going to call it X, and we're going to say joules. So we know that joules is an energy rating, so therefore we can say kilowatt hours is just an energy rating. The kilo in front is a prefix, as we looked at before here, up here, and we can see that is just a specific amount of energy. The last part for question 2, part H, is kilograms. So again, like we talked about in this last one, 1 kilo is equal to 1 times 10 to the 3. And grams, as many of us know, is just mass. So we have a specific quantity of mass. That's neither power or energy. So the correct answer for part H is neither.